Sharding is a thing that you have to do if you want to build a big system. The idea is, instead of having a network of computers that all know the same thing, and when you do a transaction, it goes to all of them, and they all change what they know the same way, instead of having a replicated state machine, a replicated ledger, instead of that, you have a bunch of them. And some of your information is in this one, and some of the information is in this one, and some is in this one. And whenever I want to change a piece of information, I tell that to just one of them to change the piece of information it's holding. Maybe that piece of information is replicated among everybody in that cluster, but the other clusters don't have to see that transaction. They don't have to remember that information. And so if I have 1,000,000 transactions, but each one is touching a different cluster, then I'll run 1,000,000 times faster than a single cluster would have run. That's sharding. You can get 1,000,000-fold speed up. And people say, hey, we have a sharded system. It'll do 1,000,000 transactions a second. That's perfect. Except when it's not. What I said was that if I had 1,000,000 transactions, each of which was being held, touching a different one of 1,000,000 clusters, then we'll run 1,000,000 times faster than one cluster would, than one shard would. A shard is one of these clusters. Like shards of glass. You have your big database is a big pane of glass. It's been broken and shattered into lots of little shards. The problem is, if I have 1,000,000 transactions, but they all have to touch the same shard, guess how fast we're going to run that? We're going to run at the speed of one shard. We didn't speed up at all. If I have 1,000,000 transactions, but they each touch a different shard, we run 1,000,000 times faster. In the real world, for any real application, you're somewhere in between. And so if somebody tells you the speed of their system, they either have to tell you the speed of a single shard, because sometimes that's the speed you're going to run at. And almost all the time, that's at least influencing the speed you're running at. Or they have to tell you the speed of the overall system for a particular exact pattern of transactions. They have to tell you exactly how the transactions interact. How often do two transactions have to touch the same shard? How often does one shard get more than its share of transactions? But if someone just says, my system does 1,000,000 a second, but doesn't tell you the pattern of transactions and doesn't tell you the speed of one shard, then you know nothing. So that's sharding. And that's the caveat emptor of trying to talk about sharding. So we want to make sure that we're doing sharding or measuring sharding the right way. But sharding as a concept is something you have to do, and everybody has to do this. What you want ideally is to build a system that has single shards that are as fast as you can get them, and then has as many shards as possible. And so with Hashgraph, a single shard can do hundreds of thousands of transactions a second. We can get latency, in a fraction of a second, or maybe around the globe in a few seconds. So this is what we've shown, in our experiments. This is good for a single shard. For a lot of applications, hundreds of thousands isn't fast enough. You've got to go to sharding. And of course, you can do that on Hashgraph, just like you can do that on anything. There's no problem with that. But you're going to be faster than you would have been if you had really slow shards for many of your access patterns. And so that's why it's important to have fast little pieces. And guess what else? Just like we can talk about whether a single shard is Byzantine fault tolerant, and whether it's the good kind of Byzantine, the fully asynchronous, we can talk about whether a whole sharded system is Byzantine fault tolerant and asynchronous Byzantine fault tolerant. And when you build your big structure out of bricks that aren't Byzantine, your big structure doesn't end up being Byzantine. But if each of your shards is running an algorithm that's asynchronous Byzantine, then there are ways to build a sharded system that is asynchronous Byzantine. It's kind of tricky, but you can do it. But if your bricks are bad, you can never build a brick house that's good. If your bricks are good, then you might or might not build a good house. You have to be careful. And so we actually can do sharding in a fully asynchronous Byzantine way because our building blocks are fully asynchronous Byzantine.